through Chris Dixon, I think. Read, write, own. What is Web 1, Web 2, Web 3, right? Read, write, own. You actually, so in the article, you call Web 3 the post-Snowden web. Why?
Mostly it was an insight that the technology. So with Web3, what I meant by Web3 was the combination of decentralization, crypto economics, and I suppose some degree of sort of usability, a sort of common application platform that could provide what people believed they got from the web, like the services that they believed they got from the web, but actually enforce the guarantees that they were, or I suppose the guarantees that they believed that they were getting from it. The reason that I specifically linked it to Snowden was because those guarantees had been broken in more than broken. Worked around, attacked, undermined. If I go to a website, I believe that the communication is between me and the website. I believe it's the same expectation as going to a shop, where the communication is between me and the shopkeeper. If I make a video call, I believe the communication is between me and the person I have the video call with. I do not believe that there is a government agent or a government department that is able to look in on my video call willy-nilly without judicial oversight. This was not the case. It should have been the case, but it was not the case. And not only was it not the case, it was a conscious determination by elements of the government to ensure that it was not the case. Snowden uncovered this, brought it to light, and there was rightfully a public outcry, and rightfully encryption soon after became widely utilized in order to help provide guarantees against various governments from infringing upon common expectations, and in cases, expectations that were enshrined in law. Web3 takes that a step further and actually says, well, it's all very well protecting the user's expectations from third parties, but what about protecting them from second parties? I might interact with Facebook in order to have a video call with my girlfriend, but I'm not protected from what Facebook does, with being that agent of communication. And especially with modern technology, it's perfectly reasonable for Facebook to analyze and potentially even snoop on that call. Now, of course, we've got things like end-to-end encryption, but that's still based on trust. I have to trust that the end-to-end encryption is in place.
Do you trust it?
Well, I have no reason to trust it.
If you think about WhatsApp or...
I have no reason to trust WhatsApp. Indeed, I can't even trust that when Signal, which is a piece of open source software, also has things like end-to-end encryption, giving me some safeguards against unwarranted snooping. But I don't know that the Signal app on my phone is necessarily the Signal code base that developers have created that I can audit, check, and make sure is legit. And this fundamental requirement of me to trust institutions and individuals that I have no reason to trust is what Web 2 is built on. And introducing HTTPS doesn't, while it plugs one particular hole, it doesn't really fix this architecture of trust. Web 3 starts from the bottom up to avoid this architecture of trust, avoid the need to trust intermediaries that we have no reason to trust, and no desire to trust for that matter.
We actually saw a clear example, I think it was 2 months ago, with Telegram, which is, by the way, used a lot in crypto. At least I would say like less technical crypto people, where even if the founder has the best interest of the people in mind, when the government comes, throws you to jail, at some point you have to do something, right? Or you end up like Snowden, hiding forever and having a tough life, which most people would not want to.
No, indeed. The social contract rears its head. Don't rock the boat.
So you said you co-founded Ethereum in 2014. Why did you join them as co-founder and CTO?
It was I identified it as an incredible opportunity and immediately realized that I should dedicate my life to this right now. Not maybe for the rest of my life, but for some period to come yet to this. It had the right combination of being innovative at the right time, have people that were competent, at least some, and dedicated, and have sort of ready and willing to understand market or public. I mean, very small slice of the public, but still. And honestly, I was curious. I thought it was a very interesting project. I thought it could really go very far and really contribute to at least what I understand are the principles of Enlightenment liberalism.
What is that?
So basically, this concept, this optimistic view of society and development that was developed in the 400 or 500 years ago in the West.
What is Ethereum's biggest achievement to date?
Maybe like CryptoKitties. I don't know. I'm not sure, actually. I heard that Ethereum made the most millionaires of any project in the history of the world, like individual millionaires. Presumably because the crowd sale was, there were lots of people in the crowd sale, and the price went up enough. So if maybe that's its biggest contribution. Honestly, it's hard to say. Like, has it actually achieved all that much that's useful? Certainly nothing along the lines of what I if you'd asked me that question 10 years ago, what I would have answered.
So if I ask you, do you consider Ethereum a success? Your answer is no.
My answer is, I think, do I personally consider it a success? Was it like a success under my metrics of success? Certainly not all of them, and probably very few. Yeah, of course it was a financial success. I mean, I think maybe I could probably name one or two founders that expected it to go even higher. But
what are some of these metrics that would have made you see it as a success?
Utility.
How do you measure utility?
The number of things that people consider useful that you can do now that you could not do before. So
is this not a crypto problem in general, rather than Ethereum?
For sure. Yeah, for sure. I mean, so one of the things that we sort of wanted to do, back in 2014, 15, it was like, we were coming up with all sorts of ways how freedom from trust could open up parts of the economy that otherwise just wouldn't be able to be opened. One of the nice ones that I like to think about was supply chains. So being able to go down to the supermarket and have the products all have a sort of QR code on, and being able to scan the QR code and see exactly what went into the product, when, where, and how much. It's like, I want to know when I buy a t-shirt, I want to know where the cotton came from. Now, this is really hard to do. It's very expensive if you're doing it in a centralized fashion, but I think it's like actually quite viable if you do it in a decentralized fashion. But it hasn't really been deployed. There are some supply chain crypto things, but they're very niche, very particular segments of the market, and it's really not living up to its promise in that regard. And I think this isn't the only. I think we have a lot of imagination in the crypto space. But it's not always easy to translate that imagination into real action and traction. And that's unfortunate. But the main reason, I think, I don't think it's the technology the technology is behind the ideation for sure. And particularly the base layer technology needs to improve a lot. And that's basically why that's my bit there. I'm working on Jam to try and improve the base layer technology to make it relevant for the sorts of ideas that I think are valuable that crypto can help with. But that's not enough. You have to make people understand the value in what it is that it does, and this is hard, in part because you're fighting with the attention economy. Absolutely.
I have an entire chapter on that. Why did you leave Ethereum in 2016?
It was late 2015. We had decided in 2015 that a lot needed to be done in order to make Ethereum be popularized, and we were looking for outside investment. So one of the ways of doing this is basically the most obvious way of doing it is to make a startup and look for outside investment, the startup being in the Ethereum space. And this is really what initially Vitalik, I, and Jeff, the sort of core coders, core engineers, had decided to do together. In the end, Jeff wasn't really up for the startup life. Actually soon after, he left Ethereum to pursue video games. Which left Vitalik and me. And Vitalik sort of felt it necessary to stick with the Ethereum Foundation and work as more of sort of an academic role, but still advise as part of the offshoot that we made at the time, Ethcore. And this we went to sort of get some funding. We took, I guess, about half of the technical staff from the Ethereum Foundation to found Ethcore. We got some funding. We made an Ethereum client. So when I sort of left the Ethereum Foundation in late 2015, it was really more of a to found this offshoot, and to do so that there could be an additional private funded entity within the Ethereum space. But I didn't actually leave the Ethereum space until I think late 2017 with the startup Polkadot.
What is Polkadot, if you had to explain it to your mother?
Well, Polkadot has changed a bit over the years. The original vision for Polkadot was to try to bring together different architectures of blockchain and make them compatible and also sit under the same security umbrella. Through sitting under the same security umbrella, it's possible to get much improved economics of scale. So you're able to essentially secure 100 chains for the same price as securing one if you have the right design. And this is in contrast to designs like Cosmos, where each of the chains has to secure itself. Indeed, for many years, Polkadot was really trying to distinguish itself from Cosmos in this sense. And it's unfortunate because the two are really solving very different problems. In retrospect, I would probably have stated that Ethereum is a sharded system. Polkadot is a sharded system, not a multi-chain system. But hindsight is 2020, especially with regards to communication. Now, this has been with Jam. This has taken a slight turn. And the technology that we developed for Polkadot, which might be characterized as a roll-up, a piece of roll-up technology. And with Polkadot, the Polkadot chain being a roll-up host chain. So a custom-made roll-up host chain. This is the technology needed for this is not trivial to develop, not trivial to come up with. And it's not super surprising that we see two competing technologies, neither of which are really delivering anywhere near as effectively as what we developed for Polkadot. So specifically optimistic rollups and ZK rollups. And these are both in use on Ethereum. So what we can sort of postulate, what we can describe Polkadot as being, maybe not for mother, but for someone that's got a bit of an idea of what's going on in the crypto space, is that it's a native rollup host chain. And what we do with Jam, which is what Polkadot will become, is attempt to turn this from a model of a multi-chain model, where we have several different chains, we call them parachains in the Polkadot world, all being placed under the same security umbrella so they can sort of interact with each other. Turning it from this into a more general computation resource. In the same way that Ethereum took Bitcoin and turned it into a more general computation resource. So we're trying to remove the opinionation, remove the design sort of scoping, and open it up to a wider variety of use cases. What specifically do I see it becoming? Basically, it's a big shared computer that always works exactly how you expect it to. And on this big shared computer, you can upload your programs to run, and your programs can be sort of services that solve particular problems. And because it's a shared computer, those services can cooperate and coordinate with each other. But what's crucial is that it's a single big shared computer. What we don't want to do is split it up into different sections and have those sections not really be able to interact with each other.
I think you're probably referring to what we both know here, which is actually creating a lot of confusion today in the Ethereum ecosystem. What is Polkadot's biggest achievement to date?
Delivering a secure, sharded blockchain.
What's the biggest problem with Polkadot today?
The fact that it's sharded.
What does that mean, concretely?
So sharding was long proposed to be the holy grail of blockchain, how you scale. And it derives its name from database design, where you will take a database, which is basically a set of records, and you split the records up into shards. And each shard operates independently of the other shards, except for some very well-defined interface, where the two shards can come together and a record, for example, might move from one place to another. Very simple physical example. Imagine an old 60s office with records, maybe like a doctor's office, medical records of the people in the doctor's office. You'll have these old drawers, right, where they put the records in. Now, if you've got like, I don't know, 20 people, you can probably fit them all into one drawer. And then it's just very easy, it's alphabetically ordered. If you have more than that, such that the records don't fit into a single drawer, you have to spread it out over multiple drawers. And then if you have more than, maybe you get 4 drawers, 5 drawers in a filing cabinet, maybe you have to have multiple cabinets. Every cabinet, every drawer might be considered a shard. they operate independently of each other. You can open one drawer without having to open all the other drawers, and you can search within one drawer without having to search through all the other drawers. It's as opposed to having just one really, really long drawer that's like 10 meters long and then pull it out and have to go through. Now that would obviously not be very practical. Like you'd need a 10-meter long room just for this one drawer that comes out 10 meters. And if you wanted to find someone whose name was W, you'd probably have to take the whole drawer out and then walk all the way up the length of the drawer until you get to W and have a look. So it makes sense to do the sharding in this regard. Now you got problems, of course. What if one drawer gets full? Now you have to take the such that all of the records from A to E no longer fit, and you need to take a record. You need to instead make it A to D and move the records of the names that begin with E down to the drawer below. And of course now maybe those records don't fit in that drawer, and you have to do the same, and the whole thing becomes very. You have to rename the label on the side of the drawer. Sharding comes with its own set of problems. But the main point is that these drawers operate independently, and so it's the case in sharded blockchain design, database design. Essentially, you move the data, you split the data up, and it stays split up persistently. Like it stays split up forever until you make a very particular action that's usually very time-consuming, very costly, very resource-intensive to actually move records, data, whatever, from one drawer, from one shard to the next. Now, this means that it might be very easy to sort of reorganize records in one drawer, but it's very hard to reorganize records across different drawers. And this is the problem with sharding. It's not so bad with data, which is probably why it's used a lot in database design, but it's really not so great with services, like with actions, with things that need to actually sort of move and change a lot, like smart contracts. Because you don't really, it's like if it's a smart contract that's in your drawers, you kind of, and you want to have the smart contract interact with the smart contract that's in another drawer, you kind of have to have both drawers out at the same time. And this sort of means, and these drawers sort of have to be out and then sort of together, so you kind of have to detach them from the thing, kind of glue them together, do all of the stuff that the smart contracts want to interact with, and then kind of unglue them and put them back in the drawers. And if you're doing it with two, I mean, that's hard enough, but if you want to do it with several, then it becomes very, very difficult indeed. And by doing this, you're preventing the drawers from interacting with other drawers, which means you kind of, all of the other smart contracts in the drawer, they're kind of stuck with just this interaction pattern. The whole thing gets very, very convoluted, very difficult, very inefficient, very quickly. Another way of doing it is to let the drawers sort of send messages. So the drawer can a shard can kind of post out a message, and at some point later it will arrive in another shard. This is what Polkadot does with XCM. It's a cross-consensus message passing. This is fine, but the problem is that you can't have very close, succinct, agile interactions nearly as much as you can as if everything is operating in kind of the same space, the same kind of playground. It's kind of like, it's the difference between, you're playing, back to, let's take another example, school playtime. Maybe your school has like 4 different playgrounds. These correspond to the sort of 4 different blockchains. Now, you might have a game of tag, right? Playing the game of tag on one playground is perfectly fine, no problem. But playing a game of tag across 2 different playgrounds is really hard because you kind of have to send a message to the other playground saying, okay, now I am it, and if you come in this area, I'm going to tag you. And then the other guys in the other playground have to then kind of know, but then not know that much, and very quickly the whole game gets kind of crazy. No, you can't really play tag across playgrounds, right? It's a game that can only be played in one playground. And that's kind of what's going on here. It's really hard to make certain solutions work if they have to work in this very asynchronous fashion, in this way where you can only play the game through messages. Now, if it's a game like chess, maybe it's not so hard. If it's a game like tag, it's basically impossible. That's kind of the case also in smart contracts. There are some smart contracts, it's not too difficult to make this thing work, and maybe it's a little bit slower than it otherwise would be, but it's basically fine. There are other games, an example of that might be identity checking, KYC. So you might have one chain that just does identity checks, and then another chain that does, transfers. And maybe the other chain wants to make sure that the destination of the transfer is KYC'd AML before they do the transfer. They send a message over, they say, hey, is it KYC AML? And the identity chain says, yes, it is. They send it back again, and the transfer goes through, and it takes like an extra few seconds, but it's like not a big problem. There are other use cases, like for example, exchanges, like DEXs, where you kind of want to say, hey, what's the price right now? I want to make a trade, and it goes over to the other chain. And the other chain says, well, the price is this, and this is what the trade would be, and it goes back to that chain. And that chain has to say, okay, I'm happy with the price, go ahead and make the trade. So it goes back again and says, okay, I'm happy with the price. And it says, actually, the price has changed. Now it's this price. And it goes back and forth, and before long, it's very difficult to come up with an effective solution to this problem. Like, basically, it has to happen all at the same time, or it can't happen at all. So it is with playground games, right? And this is really this requirement in the industry. It's called asynchronous composition versus synchronous composition. Synchronous composition is really what you want, but it's very cost intensive, right? It's resource intensive. It means everything kind of has to be in the same place at the same time. And just in the same way that, running a conference is expensive and no one spends their life living at a conference. So it is with blockchain. Like, you can't have everything all on the same shard, in the same space at the same time. So now we have to understand, okay, that doesn't scale. How do we still provide synchronous composition and therefore solutions to these kinds of problems, whilst still retaining scalability, well, keeping scalability? And this is the hard problem. Scaling in and of itself, Polkadot's already done, but scaling whilst retaining synchronous composability is difficult.
What's a viable solution to that problem?
Jam is my proposal, the join accumulate machine.
What the hell is Jam?
Jam is Jam is an agile way of bringing together different people in the playgrounds and sort of creates ephemeral playgrounds where they can play tag. So in the example, I'm making this up on the fly, by the way, so if it's a bit mad, sorry. But to take to carry on with this example of the game of tag, where you've got like maybe 4 different playgrounds, with Jam, you don't have the 4 different playgrounds. Instead, they're not fixed playgrounds. People are not beholden to a playground, and it doesn't cost that much, like with a high cost to send people between playgrounds. Instead, what we have is we have a broad play area where specific playgrounds can form and disappear very quickly. And in this case, people can, what we kind of do with the game of tag is we say, right, well, we find the people that are actually near to each other in the game of tag that might actually tag each other. And we say, right, for this little block of time, we're going to make a playground around you guys, and you play tag. And then once enough of you kind of run out of the playground, this little ephemeral playground, then we're going to reconstitute where the playgrounds are and draw a new playground around the people that are actually close to each other, where we actually have to watch out for them tagging each other. If people are far away, we know that they're not going to tag each other anytime soon, so they don't need to be part of the playground. So they're kind of just, they're not part of the game at the moment. Yeah. And if we do it this way, in a much more agile fashion, we can imagine a system that scales but still allows synchronous composability, because what it's doing is it's not persistently splitting apart what we call the state, right? So essentially drawing like having a player be subscribed into a specific playground forever, persistently. But instead, what it's doing is providing or partitioning the players on the fly and moving the game along according to these partitions, with the partitions being driven by essentially kind of which players actually need to be considered together. In the smart contract realm, what we're talking about here is taking smart contracts, having the smart contracts all sit in some very large shared crucible, but not a crucible where everything could always interact with everything else all of the time, but rather a crucible where we can take partitions of the smart contract. So basically pull out however many, 10, 50, 2 smart contracts, put them together, move them along with each other, synchronously composing, send them apart again, reconsider, take another different set of smart contracts, bring them together, move them along, send them apart again. And we can do that, but at the same time as doing other partitions, and this is how we scale, right? So we don't have to just have one constellation of smart contracts that are moving together, synchronously composing, but we can have multiple constellations of smart contracts, synchronously composing and moving together at the same time in parallel. And this allows us to process hundreds of interactions more than we would otherwise be able to.
Let's say this is the solution to every problem in blockchain, which probably it's not, right? Because probably even harder than that. But let's say it solves most of the problems. That's only one piece of the puzzle. Because to drive adoption, you need communication, you need attention. So you can build the best tech in the world, but if you don't have the attention, there's a lot of other ones out there, right, who are competing for that attention. How well do you think Polkadot is doing on this other side of the equation, which at the end of the day, it's a business, right? You need great tech, but maybe having the best tech is not going to make the whole difference if you're not amazing in communication.
I think communication is hard, and it depends on your audience, understanding your audience. And it's not something that is, the audience that needs to be communicated with is not readily obvious. And of course, you also have to understand what your goals are. Now, if your goals are to attract public attention, then you would do something like sponsor a football team, because the public watches football. Is that relevant to Polkadot? Not convinced.
Not convinced either.
If you are looking to attract VCs, you'll communicate in a totally different way. If you're looking to attract VCs, other than a pitch deck, you'll probably mostly just offer them very cheap buy-ins. If you're looking to attract the backing of enterprise, you'll market in another way. If you're looking to attract bedroom coders and small startups, you'll market in another way. You'll communicate in another way. Now, there are arguments for communicating with each of these segments of society, each of these demographics. And Polkadot here, thus far, is really focused mostly on developers. And it's, up until fairly recently, it was borne out in the numbers. Polkadot has traditionally had one of the highest developer adoption of anything beyond Ethereum. But that doesn't necessarily make it successful in the eyes, in everyone's eyes.
Because if I can just say one thing, there's this thing in crypto we say your token is your best marketing. It's very simplistic, right? But if I need to look at one kind of commonality between all these people that you talked about, at the end of the day, most of the people, the public, the developers, probably earning some tokens to develop. The VC, they're not.
They never did it. But of course, you can throw developers tokens. Sure. I mean, but you can also provide good tech and a good technological vision and a good technological platform. And this is really what Polkadot had focused on.
It's enough.
Well, again, it depends what you are setting out to achieve. And I think that there are a lot of people out there that have a very simplistic idea of what constitutes success. For example, you can take a project. There are projects out there where it's just about numbers, and it's about optimizing a certain concept until the numbers are sufficiently high, and then showing off about the numbers. It's not about delivering on the ideals of Web3, as I put out in the 2014 post. You can look at other projects that might have be able to point to a number of corporate tie-ins and claim adoption. And they're not focusing on the numbers. They're not focusing on like practical matters. They're focusing purely on business development side. That's neither of those things that we've really focused on too much in Polkadot. In Polkadot, we've really tried to deliver what we believe. What essentially, firstly, we put forth in the white paper, and this was, in part, a legal requirement. Yeah, I mean, if you sell something, then you develop what you state you were selling. Yeah? And in part, it's from a belief that in the product. And as that, as more information comes in, this product, the understanding of what makes a good product can shift. And this is partly where Jam comes from. An understanding that sharding is not the end game. But I think that a lot of people might view the space. There are a few perspectives on the space, right? One of the perspectives is, and I think this is a minority perspective, that it's a tech space, a decentralized cryptographic tech space, similar in some sense to the Tor project, right? Another group of people might see this as some sort of like anarchistic space, where it's actually about developing an alternative to banks. I think this is like kind of the proposition put forward by Satoshi Nakamoto with Bitcoin. And another group of people might have a perspective that actually what this is all about is markets and delivering, as you say, like a business value to shareholders. I do not have much. That's not how I approach the space. How I approach the space is much more in line with the first group of people. And so for me, developing the Polkadot product is in part about making it relevant. But it's also, relevance in my mind is also crucially based on the ideals and principles of Web3, which means more importantly than basically any of the other stuff, is that it has to actually deliver those guarantees that people expect with their internet interactions. Privacy being a notable one, but all the rest of it as well. And there are times when these come into conflict. Now, I think Polkadot could do a much better job at communicating this, don't get me wrong. And this is something that we are heavily focused on at the moment, like coming up with ways of presenting this and phrasing this and helping people understand the difference of Polkadot from other approaches. I think, honestly, Ethereum is one of the very few other projects that cares about doing things sort of the right way, doing things in line with the Web3 principles. Most projects are focused much more, I would say, on delivering kind of short-term factors. With Polkadot, it's really, we're building for the long run. And when you focus on the long term, and you focus your resources on the long term, inevitably, those short-term factors can be shortchanged.
What does success look like for Polkadot for you? What's the day you can say, Polkadot achieved exactly what I wanted?
Being useful, being the platform that provides Web3 to the world. Now, this is a bit of this implies that the world wants Web3, right?
Interesting.
And that is not necessarily the case. That is yet to be shown. I mean, people did move to HTTP